So, welcome back to Dumbrate. Today we're going to be doing a full bridge rectification of a transformer with one of these. This is a full bridge rectifier. It's consistent of 4 diodes set in a row, so it splits an AC wall current, that is alternating current, with a wave function. That splits it into 2 distinct wave halves, the positive and negative, that you can then use as a DC current. So step 1 is get your gloves on and make sure you've got all the parts necessary. So full bridge rectifier and a transformer. So one of these, something to strip wires with if you've got wires hanging out of it that don't have any exposed copper or whatever it is you're using. Make sure you've got a cord to plug it in, because without power, of course, it's worthless. And make sure that you've got all the proper know-how if you're going to do this, because probably should not do this at home. It's not really the safest thing. That's why I'm wearing gloves and doing it on carpet. Yeah, so now we begin. Right, so step 1, we need to take those 2 wires right there and strip them down so they're exposed, because in a full bridge rectifier you need to have 2 power inputs from the AC current. So, whoop. Almost fell over there. So you can see here, there's the negative and positive, but that's for DC current after it's been converted. So we need to put wires on these 2 leads. So I'm going to strip these 2 here, and then I'm going to attach them onto this. Okay, now I've got the wires stripped. I mean, they're not the best stripping, but it'll work. They're exposed about 1/2 to 3 centimeters. So now I'm just going to solder those on to these leads right here. You don't have to solder, but soldering I like to do because it makes this connection a little bit more secure. So soldering, tape will work too if you have that electrical tape, although if you don't know how to solder, I don't really suggest you be doing a full bridge rectification. So, you know, to each his own now. Okay, now I've soldered it onto the rectifier, so now I'm just going to attach the positive and negative leads, and then I'll plug it in and test it out. So, let's see how this works. Okay, so now I've got all the correct wiring hooked up, so the positive and negative are color-coded. I have the black on negative, red on positive, as per usual. I've elected to use jumper cables for this experiment because they're thick, easily colored, and I had 2 of them on hand. So I've now got them hooked up over here. I have one attached to a stick so I can handle it, and one is just put on the ground. Now I'm going to plug it in and see what kind of arc it gives me. And hopefully I should be able to discern the difference between that and the DC one. Or rather the AC one from the non-rectified transformer. So we'll see how this works. Okay, so it works. The current is rectified, and the difference you'll see is that it's not making an arc. What it's actually forming is a lot of sparks, and that's indicative of it being a DC current rather than an AC current. So, yeah, there you go. That is a rectified transformer.